Hi everyone, we're starting our next section, section 16D, on completing the square. Now, what we looked at in sections A, B, and C simply showed us how to solve for x when we have a quadratic. I mean, up till now, we have always solved situations where we had something along the lines of x plus 5 equals 12, or 3 over 2x minus 8 equals 17, for example, and these were all linear equations that we were solving. Now, what we are currently looking at now, though, is solving quadratic equations. And with the solving of the quadratic equations in sections A, B, and C, what we saw was that if we had questions such as x squared equaling 25, for example, well, we would just take the square root of both sides, and we could say that x was equal to the positive or negative version of 5. And we took either both the positive or the negative. So this was for quadratics. So the other thing that we took a look at was the null factor law. And in the null factor law, we took a look at questions such as this, where we said, well, let's assume that we had x squared plus 5x. And that was equal to 0, okay? And what we had to do was we had to solve for x here. So solving for x here meant that you had to remove a common factor first, since it's a quadratic, so that this would become x times x plus 5 equaling 0. And then by using the null factor law, we could say that either x was equal to 0 or x plus 5 was equal to 0. Therefore, our value of x could have been two solutions, x equaling 0 or x equaling negative 5. And what this meant graphically was that there were two x-intercepts to this parabola. So my parabola looked something like this, and we know that it had an x-intercept at 0 and another x-intercept at negative 5. So it crossed the x-axis twice. And the possible number of solutions here were either two solutions for quadratics, so two x-intercepts, one solution, or one x-intercept, or no solutions, meaning that there were no x-intercepts. Okay, so those were the three possibilities there, whereas in the linear equations, for the most part, we either have, for linear equations, we're looking at always one x-intercept occurring on a linear equation, unless we were looking at a horizontal line, in which case there would be no x-intercept if there was a horizontal line. All right, so what we're looking now at is, well, we've looked at situations such as the first two that I've mentioned here, number 1 and 2, and the third situation that I could mention would be something along the lines of if I had a quadratic such as x squared plus 6x plus 8, for example. And if that was, how about if I did this? I made x squared plus 6x equals negative 8, and then I say solve. So solve for x. So solving for x here would mean that I have to bring everything over to one side of the equation, so that this would go to x squared plus 6x plus 8, and that would be set equal to 0. And therefore, I would use the sum and product rule and say what two numbers multiplied would give me 8, but added would give me 6. And so the numbers would be 4 and 2. And then again, final step, you would use the null factor law and say that either x plus 4 is equal to 0, or x plus 2 is equal to 0, so that x would equal negative 4, or x would equal negative 2. So that would be another situation, of course. And then we can use all the other forms of factorization that we've learned with 4 terms, breaking it in half and breaking it into two groups of 2, or we could use perfect squares or different squares and so forth. There could be a series of different things going on. All right. So what we are going to look at though today is, well, what if we have a situation whereby you can't factorize it? So as an example, let's say that we had x squared minus 4x minus 7 equaling 0. All right? And keep in mind that my value of the a here is equal to 1. So I have a 1 in the front here, but I don't place it there. So it's going to be x equaling, the a equaling 1. And again, I'm solving for x. So the first thing I would initially say is, all right, let's find two numbers that multiply together give us -7, but the sum of those two numbers added together gives us -4. And the more I think about it, the more I realize that there are no two whole numbers that can give me the solution to this. Whole numbers meaning 1, 2, 3, 4, 5, or -1, -2, -3, -4, -5. But my answer is going to be a decimal answer. Okay? So as I was saying, if we had x squared minus 4x minus 7 equaling 0, then if I wanted to solve for x here in this quadratic, then I would start probably by looking at this and saying, okay, what two numbers added or multiplied give me -7 and added give me -4, which there is no number. So we bring now, therefore, given the following quadratic, we will then bring all our variables to one side. So all our x's will be brought over to one side, x squared minus 4x, and we'll bring the 7 or the -7 over the other side to turn it into +7. Now, our whole point here in completing the square is that we are going to make a perfect square. Now, if you recall, when we looked at perfect squares meant that you, I'm just going to do this off on the side, if we had a plus b all squared, you were going to square the first, square the last, and then multiply or do the product of the two terms inside the parentheses, and then multiply it by 2. Okay, so that we had a squared plus 2ab plus b squared. Now in the completing the square process, so we squared the first, we squared the last, and we did the product of the two terms and multiplied by 2. So when I am doing the x squared minus 4x, what I'm doing is I'm taking the left-hand side and I'm creating a perfect square. So what I do is, instead of multiplying the middle term by 2, what I'm going to do is I'm going to half it, so that this will go to x squared minus 4x. Now, I will take half of the 4 and I will square it, so that this will go to plus 2 squared. And then on the other side, I'm going to have exactly the same thing, which will be equals 7. Now, I'll put this in black. Equals 7. And then because I added 2 squared on the right-hand side of the equation, I'm going to place also 2 squared on the right-hand side of the equation, simply because I want to keep the equation balanced. So in doing this, if we've got x squared minus 4x, so I have now x squared minus 4x plus 4, and that equals 7 plus 4, which is 11. Now, what I have created here is a perfect square. And in creating the perfect square, and that equals 11, in creating the perfect square, I can now factorize the left-hand side of my equation. And factorizing the left side of my equation simply means what two numbers multiplied by themselves, what two numbers multiplied equal 4 and added together equal -4. And the two numbers can be none other than x minus 2 times x minus 2, or x minus 2 all squared. And that will equal 11. All that needs to be done now is that we just need to take the square root of both sides. That's our last step. So we take the square root of both sides so that we can isolate for x, and therefore we have x minus 2 is going to equal the positive or negative version of root 11. Therefore x is going to be equal to 2 plus or minus root 11. So we've got two solutions. It's 2 plus root 11 for x, or x is going to be equal to 2 minus root 11. And that's approximately going to be along the lines of 2 plus or minus 3 point something. So we obviously don't have whole number answers here, but we've got decimals. So let's just move on and take a look at the next question. So the next question says, we've got x squared minus 2x plus 2. And again, we need to solve for x. Now, because when I look at the question per se, I do not have two numbers that multiplied together will give me negative 2 and added will give me negative 2, then I'm going to move on to my next form of factorization, which is completing the square, which is what I've just done in the previous question. So the first step that I take in completing the square is I take all the x's and keep them on one side of the equation, and I put the 2, I bring the negative 2 over to the other side. Now what I do is the completing the square process. And the completing the square process says that all I need to do is write x squared minus 2x. Now I take half of the middle x term, so it's going to be plus 1, and I'm going to square it. And whatever I do to the left-hand side of my equation, I need to also do to the right. So I take 1 and I square it. Now, it is always going to be positive. I'm going to be taking the positive regardless of whether the middle x term here is positive or negative. It will always be plus. So all I have now left is x squared minus 2x plus 1 is equal to 2 plus 1, which equals 3. And what I have created is what we mentioned before, is the perfect square. And the perfect square here says what two numbers multiplied give me positive 1, but those same two numbers added together give me negative 2. So the numbers are going to be x minus 1 times x minus 1, which is x minus 1 all squared. And that equals 3. So the last thing that I need to do is take the square root of both sides. And taking the square root, I get rid of the squared. So I have x minus 1 is equal to plus or minus root 3, and therefore my value of the x is going to be 1 plus or minus the square root of 3. So I have, again, two solutions. It'll be 1 plus root 3 or 1 minus root 3. Now, I don't need to put both of those down. As long as I put my solution as here, 1 plus or minus root 3, that is more than sufficient. Now, things get a teeny bit more complicated when we start getting questions such as the next one. So let's take a look at the next one. So if I have x squared plus 3x minus 1 equaling 0, again, I'm going through this process and saying, well, are there two numbers that multiplied equal negative 1 and added give me positive 3? So the first, and I get no as an answer there. So what I do is I move to completing the square. So my first step is to rewrite x squared plus 3x is equal to 1. Now my next step is to write x squared plus 3x, and remember we take half of the middle term, which is, now I don't have an even number though, I've got 3. So half of 3 is going to be 1.5 or 3 over 2. It's easier to write out 3 over 2 than use a decimal here. So how do I get to 3 over 2? All I do is I say 3 multiplied by 1/2 or 3 divided by 2. And therefore I'm going to say plus, so half of 3 is 3 over 2, and then I'm going to square it, and that will also go on the right hand side. So it'll be 1 plus 3 over 2 squared. Okay, so now I have x squared plus 3x plus 9 over 4 is equal to 1 plus 9 over 4. When I square 3 over 2 and 3 over 2, that gives me 9 over 4. Now, the last step, or the second to last step, is completing the square here. So the completing the square says, what two numbers multiplied give me 9/4 and added together give me 3? Well, those numbers are going to be the number when I halved it, but before I squared it. So it'll be this number will tell me what the perfect square is. So it'll be x plus 3 over 2 all squared which is equal to, now I have 1 plus 9 over 4. Let's get a common denominator of 4 over 4 plus 9 over 4 over 4, and therefore we have x plus 3 over 2 all squared equals 13 over 4. The last step that we want to take is taking the square root of both sides of the equation, so that we get x plus 3 halves is equal to the square root, the positive and negative version of 13 over 4, and therefore x is equal to negative 3 halves plus or minus. Now the square root of 13 would just be 13, and the square root of 4 is going to be 2, so x will be negative 3 plus or minus root 13 all over a common denominator of 2. Now we're going to try a couple of other examples for sure here. Let's take a look at the next one. So this next example, again, let's just go through the steps one more time. So I've got x squared plus 6x plus 4. There are no two whole numbers that multiplied together give me 4, but added give me 6. So I'm going to complete the square. So what I will do is I will write out x squared plus 6x is equal to negative 4. And then I will do x squared plus 6x. I rewrite the terms again. And I take half of 6, which is 3, and I square it. So it becomes plus 3 squared. And what I do to one side of the equation, I'm going to do to the other. So that means I will do plus 3 squared on the right-hand side as well. And I have now x squared plus 6x plus 9 is equal to negative 4 plus 9. I have created my perfect square here. So what two numbers multiplied give me 9 and added give me 6? That would be 3 and 3. So it would be x plus 3 all squared is equal to negative 4 plus 9, which is 5. And therefore we now have to simply take the square root of both sides, so that I have x plus 3 is equal to the positive or negative version of square root of 5, and then I just write x is equal, I isolate for x, and I get x is equal to negative 3 plus or minus root 5. I've got two solutions there. Let's do another example, preferably one with an odd number again, so that we can use fractions. So we have x squared plus 5x minus 7 is equal to 0. Are there two numbers that multiplied equal negative 7 and added equal 5? The answer is no. So I'm going to write x squared plus 5x. I take my x's over to one side of the equation, and I bring my constant over to the other. And now I say x squared plus 5x, and I take half of 5. So half of 5 is 5 over 2, and I square it. So I do 5 over 2 and then square it. So what I really have is plus 5 over 2 all squared, and that equals 7. And again, on the right-hand side, I also add plus 5 over 2 all squared. So that this goes to x squared plus 5x plus 25 over 4 is equal to 7 plus 25 over 4. All right, now the perfect square created is going to be the number before it was squared. It was when it was halved, but before it was squared. So that this would go to x plus 5 over 2 all squared is equal to, and now I get a common denominator on the right hand side, which is going to be 4. So I multiply top and bottom here by 4, so that I have 28 plus 25 all over 4, and I end up with x plus 5 over 2 all squared is equal to 53 over 4. I take the square root of both sides, so that I have x plus 5 over 2 is equal to the positive or negative version of root 54 over 2. I just took the square root of 4 in the denominator here. And so I just bring the 5 over 2 over to the right-hand side, and I isolate for x. So x is equal to negative 5 plus or minus root 54, all divided by 2. All right. let's just do one more example, and then I'll show you a couple of other examples, and then we'll be done. Alright, so the next one is again x squared plus 6x, and there are no two numbers that multiplied give me 12 and added give me 6. So I'll write x squared plus 6x equals negative 12. And then I'll do x squared plus 6x. Half of 6 is 3, so I add 3 squared, and it's negative 12 plus 3 squared. This gives me x squared plus 6x plus 9, which is my perfect square, and that equals negative 12 plus 9. So I have x squared plus 6x plus 9. Our perfect square, when we factorize that, goes to x plus 3. All squared is equal to negative 3. And now when I take the square root of both sides, I get x plus 3 is equal to the square root of negative 3. And here I have a problem. The problem is that I cannot take the square root of a negative number. And if you recall what we had said in the previous class, taking the square root of a negative number would simply end in us saying that it is not possible to simplify, or it's not possible to solve it. And because it has no solution, what that is referring to is the fact that there are no x-intercepts. Remember that we're always looking for the x-intercepts. And because I have a negative under the square root, that means that there are no x-intercepts. So my graph is probably something like this, or something like this. Well, it's definitely facing upwards, so that I know that the graph is somewhere up here. Okay, and it's not touching the x-axis. The only other question that I'd like to go over is a question whereby our value of x, our value of the a, is not equal to 0. So all of the questions we've done so far have had the values of the a equaling 0. The only thing that changes in the problems with the a not equaling 0 is that you're going to divide both sides by whatever the value of a is to remove the value of a from the x squared. So given the problem that you see in front of you now, 2x squared plus 4x minus 1, I would divide both sides by 2, because 2 is in front of the x squared. So everything gets divided by 2, so that this would go to 2x squared over 2 plus 4x over 2 minus 1 over 2 equals 0 over 2. So that this would go to x squared plus 2x minus 1/2 equals 0. And then I would proceed to solve as I did all the other questions. So I would say, are there two numbers that multiplied together give me negative 1/2 and added give me negative 2, positive 2? No, there aren't. So I say x squared plus 2x equals 1/2. X squared plus 2x, and then it's plus 1 squared equals 1/2 plus 1 squared. This is a perfect square of x plus 1 all squared is equal to, well, 1 plus 1/2 is going to be 1.5, and 1.5 is 3 over 2. I now take the square root of both sides to isolate 4x. So I take the square root of both sides, and I get x plus 1 is equal to plus or minus the square root of 3 over 2. And therefore my final answer goes to x is equal to 1 plus or minus root 3 over 2. If I want to simplify this, it would be as 1 plus root 3 over root 2, which means I'm going to multiply the 1 by root 2 over root 2 to get a common denominator. And so x would be root 2 plus root 3, root 2 plus root 3 over root 2. But then we would have to rationalize the denominator. And rationalizing the denominator, as we saw in the last chapters, means that I will write it as x is equal to root 2 plus root 3 times root 2 over root 2 times root 2. So I'm multiplying by whatever the denominator was, and I end up with 2 plus root 6 over 2. I did root 2 times root 2 is root 4, and root 4 is 2, Root 2 times root 3 is root 6, and root 2 times root 2 gives me 2. And that would be my final answer, 2 plus root 6 over 2. Okay, last question. I'll just do one more. Let's take this example here. So we have 3x squared minus 6x plus 2 equals 0. Well, I'm going to divide everything by 3. So I end up with x squared minus 2x plus 2/3 equals 0. I will get x squared minus 2x equals negative 2/3. X squared minus 2x plus 1 squared equals negative 2/3 plus 1 squared. Now this goes to x minus 2x plus 1, and that equals, negative 2/3 plus 3/3, so that I get x minus 1 all squared is equal to 1/3, and therefore now taking the square root of both sides, I get x minus 1 is equal to the positive or negative of 1 over root 3, because the square root of 1 is just 1, and root 3 is root 3. I can rationalize this, and maybe I'll rationalize it now to x minus 1 equals the positive or negative of root 3 over 3. And so x is equal to 1 plus or minus root 3 over 3, which if I get a common denominator, it would go to x is equal to 3 plus or minus root 3 over 3. And that would give us our final answer. All right, so the work that you'll be doing would be exercise 16D, all of it. See you next time.